Section 10.2, checking conditions for a multiple regression model, video 4. It dawned on me after the last video that I probably could have just said what I'm about to tell you. I probably could have said what I'm about to tell you without the need for the illustration, but I like for things to jump out naturally instead of just me saying, I'm the professor and I said it, so it must be true. It's kind of arrogant in my opinion. But so here's the thing about residuals versus fits plot. For a multiple regression, and it's actually true for a simple regression, but a simple regression is in 2 dimensions already, so there's no need for a residuals versus fit plot. But for a multiple regression, a residuals versus fits plot preserves curvature, increasing variability, and although it hasn't ever been mentioned, decreasing variability is a thing too, where the points start out really far away from the line and they converge on it, but that would be a case for not using a linear model either. And outliers. Things that we can't see in 3 or 4 or 10 dimensions, but we can easily see in 2 dimensions. This is usually taken care of with technology, where you enter all of your data points, however many dimensions it is. If it's 4 explanatory variables and 1 response, then it's 5-dimensional. So you would have 5 columns of numbers. But it can generate a residuals versus fits plot for you so that you can observe visually whether or not a linear model is appropriate. If you see curvature, you should not use a linear model. If you see increasing variability, so in a residuals versus fits plot, that would be the points increasing away from the 0 line. And of course, outliers, you see a point that's lying way out there away from everybody else. If you spot an outlier, you can throw it out and recalculate and get a better model. But you should be careful when you're using a linear model and there are outliers present.